There's a point between Earth and the Sun where gravity cancels out. It's still, invisible, and perfect for watching the cosmos. You drift there now, weightless, watching the star from a quiet edge. This is where space stands still, far. Above the clouds, past the pull of weather and wings, you drift beyond the Earth's gentle grip. Here, between two giants, the Sun and the Earth, you find something strange. A balance point. Unseen, yet real. A place where forces meet and cancel, like two hands pressing equally on a string. It's called Lagrange, point 1, or just L1. But names don't matter when you're floating. What matters is the stillness. You're no longer falling toward the Earth and not yet being pulled into the Sun. You are suspended, not by ropes or engines, but by agreement between gravity and motion. Around you, space curves gently. Photons pass in silence. Satellites sometimes come here to not for the quiet, but for the view. From L1, the sun never sets. It hangs there, fixed in your sky, like a lantern that never flickers. This is where we placed Soho, a spacecraft that listens to the sun's whispers. It watches for flares and storms, warning Earth before the solar winds arrive. Another companion, DSCOVR, peers both ways, toward the sun and back toward Earth, measuring how much energy our planet breathes in and out. And you simply float. You close your eyes and feel the sun's warmth, not as heat, but as presence. There's no wind, no sound, no weight, just balance, pure, gentle, perfect. It isn't magic. It's math, written into the fabric of space. Where gravity and orbit dance just right, a pocket of calm appears. 5 such places exist between the Earth and Sun. But L1 is the only one that watches the star from the front row. You're not anchored here. Satellites drift slightly, looping in quiet halo orbits to stay close. It takes small corrections, soft pushes, to remain in this delicate alignment. But the effort is worth it. Here we can look ahead. As you breathe in this balance, you begin to wonder if space has these still points. What other slow surprises does it hide in time? You close your eyes and feel the turning of planets, and somewhere in the dark, you sense that not all days pass as they do on Earth. ... Now you drift toward a world wrapped in pale gold. Thick clouds swirl beneath you, whispering in slow motion. Beneath the haze lies Venus, a planet the same size as Earth, but built from a rhythm not your own. The surface turns so slowly, so reluctantly, that a single Venus day takes longer than its year. You watch, gently suspended above the clouds, and time stretches out like warm honey across stone. To spin once on its axis, Venus takes 243 Earth days. But to orbit the Sun to complete its year, only 225 days pass. Here the Sun rises once and sets long after the year has ended. The sky holds the same light for months at a time, then gives way to dusk, as if remembering it had forgotten, and just when you expect normalcy, Venus rotates backwards. Retrograde, a rare reversal, like the hands of a clock turning the wrong way. If you stood on the surface, the sun would appear to rise in the west and set in the east. Time unfolds in reverse. You imagine the stillness, the long shadow of a mountain unmoving for weeks. The sky painted with the same shade of ochre for months. The air thick with carbon dioxide and clouds of sulfuric acid. Presses down with 90 times the weight of Earth's atmosphere. It holds the heat in like a sealed furnace, crushing, unmoving, complete dot. Why does Venus spin so slowly? Some say tidal forces from the sun changed it. Others suggest a great collision long ago. But no one knows for sure. And in that mystery, Venus remains quiet, a planet wrapped in secrecy and slow-burning fire. Despite the heat and pressure, the silence of its spin draws you in. Time doesn't hurry here. It melts, it pools, it waits. And as you float above its clouds, you feel the weight of unspoken hours. You wonder what it means for a planet to turn so reluctantly. And you ask what else in the solar system behaves in ways that seem impossible and yet are true. Now, your journey takes you to a place of grandeur, a world so massive, so beautifully wide, that it wears rings like a crown of frozen light. This is Saturn, the second largest planet in the solar system. And yet, despite its size, you learn something strange. If there were a bathtub big enough, Saturn would float. It sounds like a trick, like something from a dream, but it's simply a matter of density, a measure of how much mass is packed into space. Saturn is made mostly of hydrogen and helium, the two lightest gases in the universe. So even though it's huge, more than 95 times more massive than Earth, it's spread out like foam, soft and wide and light. Its average density is less than water. That means if you could place Saturn on a vast ocean, it would bob gently, like a leaf on a pond. Not that such a sea exists, but still the image floats in your mind. You drift along its rings, which aren't solid, but made of countless icy fragments, some as small as pebbles, some as wide as houses. They orbit Saturn in delicate harmony, a shining echo of its weightlessness. And yet Saturn has gravity strong enough to hold over 80 moons. You feel the contradiction settle gently in your thoughts. Saturn is heavy, but not dense. It pulls, but it floats. A giant, yet light as a whisper. You think about what floats and what sinks, about things that appear heavy but carry little beneath the surface. And planets, just like people, can be full of surprises. Beneath the clouds, there's no surface to stand on, only deeper and deeper layers of gas, pressing inward under gravity's hand. There may be a small, solid core, but you'll never reach it. There's nothing to land on. You'd simply fall forever as you drift away from Saturn's rings. You carry with you a quiet realization. Not everything big is heavy, and not everything weightless is small. And just beyond the golden crown of Saturn, a red giant waits, a planet with a storm. That has raged for centuries. Now you float toward the largest of all planets, a swirling giant of gold and rust, striped with bands that never stop moving. This is Jupiter, and below its clouds waits something ancient, a storm, a scar, a colossal eye that watches from a canvas of gas. You drift above the great red spot, a storm larger than Earth, spinning endlessly in Jupiter's southern hemisphere. Its color is deep and strange, like old brick or faded fire. It turns with quiet power, its winds blowing faster than any storm on Earth, over 400 kilometers per hour. The great red spot has been spinning for at least 400 years, perhaps longer. It was first seen through telescopes in the 1600s, and it's still here, still churning, still circling between Jupiter's roaring jet streams. You hover above it in silence. There's no ground, no ocean, no landfall, only clouds, layer upon layer, each one moving in a different direction, like a symphony of winds. Lightning flickers in the distance, brief as a blink, but fierce as memory dot. Unlike storms on Earth that rise and vanish, Jupiter's great red spot endures. Its roots may reach hundreds of kilometers deep. It is not a surface storm. It is a column of energy, a spinning tower of pressure and heat with no floor, no end. Beneath it, the planet pulses with internal warmth. Jupiter radiates more energy than it receives from the sun. Its core is dense and hot, but you will never see it. You float above the atmosphere, listening to the winds that have outlived generations. No one knows how long the storm will last. It has shrunk over time, changing shape, softening color, but it still turns, still watches, still waits, and you wonder what keeps something spinning for centuries. What feeds it, momentum, heat, or memory? As you drift westward, you catch the edge of something small, tumbling in irregular motion. Not a planet, not even a sphere, a moon. One that spins without pattern, far beyond the swirling giants. Beyond Saturn's golden rings and quiet storms, you find something small. Not a planet, but a moon unlike any you've seen before. This is Hyperion. It doesn't glide with grace. It stumbles, tumbles, and turns unpredictably, as if it never learned how to spin properly. No rhythm, no steady face. Each rotation is a surprise, even to the moon itself. You drift beside it in slow orbit, watching it roll like a tossed pebble. In space, its shape is strange, not round, not smooth, but dented, jagged, porous. It looks like a sponge, its surface full of sharp-edged craters that never smoothed out with time. Hyperion is made mostly of ice, but it's incredibly light. Its interior is so empty that it can't even compress. When meteorites strike it, they don't flatten the surface. Instead, they carve deep pits with steep sides, as if the moon simply absorbs the blow and holds the memory. It's one of the most chaotic rotators in the solar system. No two spins are alike. No axis is fixed. Hyperion tumbles because it's irregular in shape, and because it's caught in a gravitational dance with Saturn and its larger moon. Titan, you imagine standing there, but there's no gravity to press your feet into place. Just a light push would send you drifting off, your voice vanishing into the vacuum. Even dust would float like thought. There is something humbling in this disorder. Most moons obey. They face their planets with predictable grace, locked in time. But Hyperion is the exception. It reminds you that even in the cosmos, not everything spins the way we expect. You watch it twist in silence, each rotation a quiet rebellion, a moon that has never danced the same way twice, and as it rolls away, you wonder what secrets might hide beneath surfaces that seem still, but are not. Your eyes turn to another distant world, where under layers of frost, an ocean may be waiting in the dark dot, far from the warmth of the sun, where light fades into soft grey and time forgets to hurry. You find yourself gliding over Pluto, small, distant, cold, and still. At first, it seems lifeless, a world of frost and quiet plains. The air is thin, the sky a dim twilight, nothing stirs. But stay long enough, and you begin to notice. Pluto is not just still, it's holding its breath. You pass over Sputnik, Planitia, a wide basin of smooth nitrogen ice, and you sense something underneath. Not rock, not air, but something softer. Something liquid. Scientists believe Pluto may hide an ocean beneath its crust. Not on the surface, where it's far too cold, but deeper down, beneath a thick layer of insulating ice. This sea may stretch for miles, kept from freezing by the warmth of radioactive decay, or perhaps by ancient heat that never escaped. You drift slowly, as if to hear the quiet slosh of a buried sea. No waves, no sunlight, just darkness, pressure, and the slow movement of water where none was expected. On Earth, oceans teem with life. On Pluto, no one knows what might dwell beneath the ice. Maybe nothing, or maybe chemistry stirs quietly in the shadows, molecules reaching for something more. What would it feel like to float beneath that frozen shell? No sky, only water, stretching in every direction, held in place by cold and gravity. You imagine the slow turning of a hidden tide, guided not by a moon, but by the shape of Pluto itself. We once thought this world was silent. Now we know it's still changing. Canyons split the crust, plains are resurfaced. Something stirs, even in this frigid exile at the edge of the sun's light. You rest in the orbit of possibility, wondering what warmth can survive in such cold. And then your attention shifts to another pole, to a planet where geometry spins in the clouds. 2. A world whose storms trace out a perfect six-sided shape. Now you return to Saturn, but not for its rings, nor for its moons. This time your gaze turns north, to a place where wind becomes geometry. High above Saturn's north pole, a storm spins with strange precision, not in circles, not in spirals, but in a hexagon, a perfect six-sided shape carved into clouds. You hover above it, silent, watching it rotate like the petals of a frozen flower. Each side is hundreds of kilometers long. The entire structure could fit to Earth's inside, and yet it remains steady and unchanged, as if drawn with a ruler on the swirling gas. What you see is not solid. It's made of clouds, a high-speed jet stream wrapping around the pole at over 300 kilometers per hour. And still the shape holds, like a machine, like a whisper of design. How can wind form a hexagon? Scientists have tried to replicate it. In labs, spinning fluids, stirring gases, and sometimes, with just the right motion, polygons appear. But Saturn's version is vast and enduring. It has been observed for decades, first by Voyager, then by Cassini, each mission confirming the same beautiful mystery. The hexagon does not wander. It doesn't drift across latitudes. It's locked to Saturn's rotation, spinning in sync with the planet below. And at its center, a great storm swirls like a silent eye, a hurricane with no end. You float above it, and it feels impossible, like seeing a snowflake the size of a continent. And yet here it is, proof that even chaos can find shape, that even winds, left long enough to dance, can draw with perfect symmetry. As you begin to drift away, the edges of the hexagon blur softly behind you. A memory etched into cloud, and you wonder if pressure and spin can create crystals in air. What strange weather might form on colder worlds, worlds of ice, where storms fall not as rain, but as something harder. You drift now toward the edge of the visible planets, where the sun is only a pale glow, and time feels slower. Neptune and Uranus, twin giants of soft blue and green, wait in silence. They turn slowly in the dark, veiled in clouds and mystery. From far away, they seem peaceful, but deep inside, something astonishing may be happening. It might be raining diamonds. Both planets are rich in methane, a gas made of carbon and hydrogen. As you move downward through the layers of atmosphere, the pressure builds. The temperature rises, and something quiet, something invisible, begins to change. Under immense force, hundreds of thousands of times, Earth's pressure carbon atoms break free. They rearrange, they crystallize, they fall. Not as dust, not as soot, but as solid diamonds dropping slowly through the fluid sky. You picture it, a rain of gemstones, glittering like stars in the dim light. Some may be small, others as large as hailstones, or even larger still, falling for thousands of kilometers before melting, sinking, or vanishing into the molten heart below. No one has seen it directly, but experiments on Earth have recreated these conditions in the lab: a flash of laser light, a shock of pressure, and diamonds form briefly from methane gas. It's real, it's possible, and out here it might be common. You float just above the upper clouds, where winds whip at incredible speeds, up to 2,000 kilometers per hour on Neptune. Below, a sea of liquid hydrogen churns slowly, and farther still, a warm heart beats. In darkness, the outer planets don't shine like the inner ones. They whisper their wonders. They hide their storms behind beauty, and their beauty behind physics. You listen to the stillness and imagine the weight of diamonds falling endlessly into a sea. No one will ever walk upon dot. And then you look toward the morning star, a planet far closer, but even more hostile. A world where visitors are crushed, not dazzled. Now you turn back toward the inner planets, toward brightness, toward heat. Venus appears, beautiful and golden, cloaked in swirling clouds that glow softly in sunlight. It looks like a sister to Earth, similar in size, shape, and silence. But as you descend, you begin to feel the difference. The clouds are not gentle mist, they are thick with sulfuric acid, opaque, yellow, and burning. They hide a surface of unrelenting power. You pass through layers of atmosphere so dense they press against you like stone. The pressure on Venus is 92 times greater than Earth's, as if you stood 1 kilometer beneath the ocean. Here, metal buckles, probes collapse, everything yields dot, and then the heat. Even before you reach the ground, your instruments begin to melt. The temperature rises past 460 degrees Celsius, hotter than the surface of Mercury. Though Mercury is closer to the Sun, Venus traps its own heat, held tight by a sky thick with carbon dioxide. In a runaway greenhouse effect, you touch down. Softly, but the planet does not welcome you. The ground is dry, fractured, and quiet. A world of old lava plains and broken rocks. No wind, no water, no sound. Just pressure and fire. Past missions, like Venera from the Soviet Union, survived. Only 4 minutes here. Cameras failed. Cables melted. Some probes lasted just long enough to send back haunting images. Smooth stones under a mustard sky. A glimpse of silence under crushing weight. You imagine standing here. Breathing would be impossible. Your suit would fail. The heat would find you. The pressure would squeeze you inward until even thought bends. And yet, Venus wasn't always like this. Long ago, perhaps it held oceans, clouds of water, not acid. A surface where rain fell, where rivers moved through stone. But something changed. The balance broke, and the planet sealed itself in heat. You float upward now, rising back through the choking clouds. Venus fades behind you, hostile, brilliant, and silent once more. And as you drift away, your gaze turns toward another moon, where strange rain still falls, not water, but something just as alien. You drift now to Titan, the largest moon of Saturn, where the skies are thick and the light is golden and dim. The air here feels close, heavy with haze. And the colors are unlike any you've seen. Honeyed orange, dusky gold, and quiet brown dot. Titan has an atmosphere, a true sky, rare among moons. It breathes a strange wind, made mostly of nitrogen, like Earth's, but mixed with methane and other hydrocarbons. You descend gently, feeling not fear, but wonder, as if stepping into a dream crafted by another kind of chemistry. Clouds gather above, slow and cold. They don't bring water. They bring liquid methane, which falls like soft rain across ancient landscapes. You hear the pitter-patter of droplets, not made for drinking, but for shaping canyons, filling lakes, and carving this distant, silent world. You walk along a shore, where methane lakes shimmer dark and glassy. Some stretch for hundreds of kilometers, like seas on Earth, but smooth as oil and colder than ice. The temperature here is nearly -180 degrees Celsius, cold enough for methane and ethane to become liquid, cold enough to slow time. The ground is solid beneath you, but it's not rock. It's frozen water, ice as hard as granite in this deep freeze. Rivers of methane once flowed here, cutting paths, leaving braided valleys where the rain returns again and again. You imagine the slow rhythm of weather, storms that come rarely but reshape the land when they do, puddles that last for centuries, a hydrological cycle that follows rules you've never known. This is not a lifeless world, just a quiet one, governed by elements we don't call home. And still, you feel something familiar, the weight of air, the curve of a horizon, the memory of water reimagined in alien form. You sit near the lake's edge, watching gentle methane waves lapping at frozen sand, and you wonder if lakes can form without water, what else might take shape in the dark and distant moons that circle the giants. Above you, a small misshapen moon begins to rise, not smooth, not steady, but tumbling dot. You drift close now to the innermost world. Mercury, the quiet guardian of the solar furnace. It moves quickly around the sun, but within itself it is slowing down. No clouds cover its face. No air softens its contours. You see everything bare rock, long shadows, and old wounds. At first, the scars seem random, but as you float nearer, you begin to notice a pattern, wrinkles, pressed into stone. Mercury is shrinking, not in ways you can see all at once, but over billions of years. Its entire surface has pulled inward, like clay drying in the sun. Its core is cooling, and with cooling comes contraction, a slow, steady tightening of a planetary shell. You hover above one of its many lobate scarps, long curved cliffs that rise suddenly from the crust. They stretch for hundreds of kilometers, as if the planet has folded itself from the inside out. This is no accident. These are stress lines, wrinkles etched into a surface that is still settling into itself. You imagine the slow groan of ancient rock as pressure builds beneath, and then releases. There are no tectonic plates here, no drifting continents, just one great body cooling from the inside and pulling tighter with time. In places, the cliffs cut through craters. That tells you something. They are younger than the impacts. The surface changes long after it should have stopped. Even now, Mercury may still be shifting quietly, gently, inward, and all this happens in silence. There is no atmosphere to carry sound, no weather to erase the old lines, only sunlight and shadow tracing the story of a planet that once burned with birth and now leans toward stillness. You float backward, carrying the image of a wrinkled world, not aged by storms, but by the quiet sigh of heat leaving its core. You, Turn your gaze outward again, towards something that's slowly leaving us, to not shrinking, but drifting. A companion of night, pulling away inch by inch. You look up at the moon, bright and steady in the night. A companion so familiar, you almost forget it's moving. But it is, quietly, slowly. The moon is drifting away. Every year it slips, just a little farther from Earth. Only about 3.8 centimeters, the width of your fingernail. A distance so small it hides in your breath. But across millions of years, the inches become miles, and the miles become memory. You imagine Earth long ago. The moon loomed closer in the sky, larger, brighter, its pull on the oceans stronger, its shadow falling heavy in eclipse. Tides crashed higher then. The days were shorter, just 5 or 6 hours long. You drift with the moon now, hovering above its silent surface. It turns slowly, always showing the same face. That's not chance. It's gravity's way of settling into balance, locking one side to always face us, while the other stays hidden, like the quiet part of a story. The reason for the drift lies in the tides. Earth's oceans stretch slightly toward the moon, pulled by its gravity. As Earth spins, these bulges drag against the moon, tugging it forward in its orbit, giving it energy. That energy has a cost. As the moon climbs higher, Earth spins more slowly. Our days lengthen, our nights deepen. The clock doesn't tick, it stretches. You sit on an imagined shore, feeling the tide touch your feet. That tide is older than language, older than bones. It has shaped coasts, written rhythms into coral, and rocked life in its cradling arms. One day, perhaps billions of years from now, the moon will stop drifting. It will reach a place of balance where Earth's rotation matches the moon's orbit. Then both will face each other in perfect stillness, locked in a timeless gaze. But that is far away. For now, the moon continues its slow retreat, and we keep watching as it pulls away. You turn your thoughts to something invisible, a force stronger than tides, reaching far beyond the moon's orbit, a field that stretches from a planet all the way to its distant moons. Jupiter, the great protector, the thunderer, its swirling storms are vast enough to swallow worlds. But today you don't dive into its clouds. You explore what surrounds it, what stretches far beyond what eyes can see. Jupiter has a magnetic field so large, so powerful, it forms the largest structure in the solar system besides the sun's own reach. If it were visible, it would appear wider than the moon in our sky, even from Earth. You float within this invisible sea. It isn't water. It's made of charged particles, flowing in loops and arcs, guided by magnetic lines that twist like threads of light through space. This field is created deep within Jupiter by its spinning core of liquid metallic hydrogen. The planet turns quickly once every 10 hours, and this spin, combined with its immense size, generates a magnetic embrace that stretches millions of kilometers in every direction. Its reach extends to the orbits of its moons, Io, Europa, Ganymede, Callisto, each one touched by this field, each one reacting in a different way. You ride the wave toward Io, where the magnetic field tears particles from its volcanic surface and sends them flying into space. A torus of plasma wraps the moon like a ribbon of fire. You glide next to Europa, where the field whispers through its icy crust, stirring electric currents in the ocean hidden below. The moon sings back in silence, its waters listening. Ganymede, the only moon in the solar system with its own magnetic field, creates a magnetic bubble inside Jupiter's own. A dance of fields within fields, each one bending space and charged energy without ever making a sound. Jupiter doesn't just spin, it shapes the space around it. Its field protects, sculpts, and stirs. It connects its moons through lines that cannot be seen but can be felt. You drift along these currents, feeling their pull, and you wonder what it means for a world to have a force that holds even the airless close. And just beyond, you sense a place so distant, so shadowed, that even the sun feels far. Now you drift to the edge of Neptune's reign, where the air is gone and only frozen light remains. Here, in the farthest reaches, a moon orbits unlike any other Triton, Neptune's cold companion, the rebel. You float beside it, watching as it moves in a direction no other large moon dares, backward, retrograde, while Neptune spins one way. Triton orbits the opposite, a path that defies the planet's rhythm. Most moons are born with their planets, shaped from the same swirling disk of dust. But Triton is different. It was captured, a wanderer, once free, pulled into orbit by Neptune's gravity long ago. You imagine that moment. Two massive objects caught in a slow collision of fate. A passing body dragged into orbit, its freedom exchanged for eternal resistance. Since then, Triton has circled in defiance, backward and proud. The consequences are still unfolding. Triton's orbit is decaying, slowly drawing closer to Neptune. Millions of years from now, it may fall inward, ripped apart by tidal forces, its pieces forming a new ring, a final spiral etched in memory. But today, it remains whole. You hover over its icy plains, where geysers burst from beneath the surface, sending plumes of nitrogen into space. They arc silently through the dark, like breath exhaled from a frozen lung. The surface is smooth in places, hinting at reshaping renewal. Triton is geologically active, even here, in a place colder than any mountain on Earth. No sunlight truly warms this world. The heat comes from within, from friction, from past collisions, from Neptune's distant pull. You glide over a place that seems still, but pulses gently with unseen forces. There's a loneliness to Triton, an orbit against the tide, a life spent circling in quiet rebellion. And yet there is beauty in the backward. Not everything needs to move with the crowd. Not everything that is captured is lost. You drift farther from Neptune now, beyond its pull, toward a boundary not drawn by planets, but by light itself, where the sun fades and something strange begins. Now you turn inward, toward the middle of the solar system, between Mars and Jupiter, where the asteroid belt waits. A name that conjures chaos, like traffic in space. A storm of tumbling stones. But as you drift into its heart, you see the truth. This belt is vast, and mostly empty. There are millions of asteroids. Yes, fragments of rock, ancient and quiet. But the space between them stretches wide, silent and dark like the pause between breaths. You glide through it, passing solitary travelers. Some are the size of pebbles, others like cities. Yet none come near you. The belt is not a wall. It's a thin veil of drifting relics spread across hundreds of millions of kilometers. These rocks are the leftovers of formation, pieces that never became a planet. Not enough gravity, too much interference. Jupiter's pull stirred the region, kept these fragments apart. A planet that almost was, but never became. You pass Ceres, the largest of them all, a dwarf planet with icy secrets, its surface marked by salt and shadow. It too is quiet, It spins in slow solitude, orbiting not as ruler, but as witness. The rest drift like thoughts, the remnants of collisions, the dust of time. Each one carries a story, written in craters, in composition. In motion, you expect to hear them collide, to see impacts in the distance, but they rarely meet. They pass one another with respectful space, as if each remembers how to keep its distance. Even here, where we imagine danger, space teaches stillness. A reminder that vastness isn't always filled, that emptiness too has shape and story. You look around, not at what is present, but at what is not. And in that absence, you find calm. Ahead, the belt thins, and the planets begin again. You drift toward warmer worlds, but carry this emptiness with you, a space between thoughts. A silence between stars, and just beyond that silence, a crater waits on a red planet, carved by impact, filled with mystery. From the quiet, drifting emptiness of the asteroid belt, you return to one of its largest bodies, Ceres, a dwarf planet nestled between Mars and Jupiter. It doesn't shine like a star, but something about it glows, not with heat, but with memory. Ceres is small, roughly 1,000 kilometers wide, tiny compared to planets, yet round, whole, and ancient. You descend toward a wide crater where the sunlight catches something strange. Bright patches, scattered like frost on a cold stone. But these aren't ice. They are salt crystals, left behind by briny water that once seeped from below. You land near a crater, where a dazzling spot reflects the light like powdered stars. These salt deposits aren't just remnants. Some may be new, formed in recent geological time, suggesting that Ceres may still be active, at least beneath its dusty skin. Long ago, a mixture of salt water and mud may have oozed up through fractures, slowly evaporating in the vacuum of space, leaving behind these glowing scars. You reach out gently, imagining the warmth that once pushed from below, a planet trying to speak through ice and salt, even now. The salts may draw moisture from the airless sky, glimmering faintly, their brightness preserved in silence. Atmosphere smears the glow. No winds erase it. You sit beside this luminous wound, not fearful, but moved. It is not dramatic, not volcanic, not stormy, just a quiet, shimmering memory of liquid becoming light. Ceres is not lifeless. It holds chemical energy, water, and the will to change. It reminds you that warmth does not need fire, and that even in the coldest places, something can rise. You take one last look at the salt-shimmered ground, then rise slowly into orbit, carrying the light with you. And now, as your path curves toward a red world ahead, you wonder what happens when ice meets dust on a planet with a past in questions buried beneath the soil. You drift now toward Europa, one of Jupiter's many moons, but unlike the others, Europa does not roar or flare or crumble. It glows, a quiet, icy orb, wrapped in stillness. From above, it looks like glass, smooth, pale, and lightly scratched. But those scratches are more than marks. They are fractures, splinters through the crust, etched by tides and hidden heat. You glide lower, skimming just above the surface. The ice is not gentle. It's hard, bright, and broken. Long cracks stretch for hundreds of kilometers, like veins or scars. Some are wide, some narrow, many tinged with reddish-brown. You follow one and feel the pull of something beneath. Europa's surface is a frozen shell, but underneath there is water. An ocean, perhaps twice the volume of all Earth's seas combined, held beneath kilometers of ice, warmed by tidal. Flexing from Jupiter's gravity, it remains liquid. Moving in the dark, you pause above a ridge, a place where the ice has split and shifted. It rises like frozen tectonics, slabs of crust pushed and pulled by unseen currents. This world is active, quietly reshaped from below. Here, water may once have risen, leaking up, freezing fast, leaving behind a memory of the ocean's breath. Perhaps life, too, waits below, not in sunlight, but near warm vents, where chemistry and time do their slow, sacred work. You imagine the pressure, the darkness, the potential. A sea untouched by wind or sky. A world without land or storm. Only water and the soft vibration of motion. Europa does not speak, but it listens. It listens with its cracks, its shifts, its silence. You skim the surface one last time, feeling the ice beneath you thrum with possibilities you cannot see. And as you rise again, your gaze returns to Jupiter, a planet so massive its pull warms distant moons. But now you look beyond even that giant, toward a place where warmth is not needed for fire to fall. Far from the warm glow of the sun, beyond the golden rings of Saturn, you arrive at a moon that breathes in silence, a world of white light, cold curves, and secret oceans. This is Enceladus, a moon wrapped in smooth, bright ice, reflecting sunlight like a polished pearl. It seems still, but when you drift near its southern pole, you see the truth. Enceladus moves. It speaks in geysers from long fractures in the ice. Nicknamed tiger stripes, jets of water vapor erupt, rising hundreds of kilometers into space. Each plume is a breath, a moment of warmth escaping into the cold. You hover near one, now watching as fine ice particles glitter and swirl in Saturn's faint light. They form a halo, a misty exhale that feeds one of Saturn's rings, the E-ring built from Enceladus's breath. These geysers don't come from surface frost. They rise from an ocean beneath the crust, a deep, global sea kept liquid by tidal forces, the push and pull of Saturn's gravity, warming the interior like a hand stirring water in the dark. Beneath that icy shell, scientists believe the water touches rocky seafloors. There, hydrothermal vents may bubble, just as they do in Earth's oceans. And where warm rock meets water, chemistry begins. Not chaos, but potential. The building blocks of life could swirl unseen beneath your feet. You float through the mist, your skin catching frozen droplets that once touched alien salt, heat, and movement. A world with no land, no air, but still a pulse. Even in deep space, life may whisper. Not with voices, but with patterns, energy, warmth, cycles, repeated again and again. Enceladus doesn't shout, it doesn't glow. It simply releases its ocean into the stars, telling you, softly, that something stirs below. You drift away, watching plumes rise behind you, like signals to a sky that rarely answers. And as your path bends toward darker regions, you wonder what other moons might keep. Oceans hidden, not beneath ice, but beneath thick blankets of air. You float beside Earth now, but not looking down at oceans or cities. You look outward, beyond the moon, beyond the familiar, because Earth is not alone in its orbit. It moves with companions, hidden in the folds of gravity. They are called Trojans, asteroids that share our path around the sun. Traveling in harmony, you glide into one of these quiet regions, a place where gravity balances just right, not too strong, not too weak. These spots are called Lagrange points, and two of them L4 and L5 sit like invisible cradles ahead of and behind Earth in its solar dance. And in those cradles, small asteroids drift. They don't crash into us, don't race past, they simply follow, riding the same track. Like distant echoes of our motion, you pause in the sunlit stillness of L4, where Earth is just behind you, and a Trojan asteroid sits quietly, tumbling slowly, unbothered. It has been here for millions of years. A passenger you never knew was riding with you. The sun blazes on one side, the black of space yawns on the other. But here, everything feels balanced, as if gravity is holding its breath. We've only recently confirmed them. Earth Trojans are few and hard to see, lost in the glare of daylight. But they are there, like silent watchers keeping pace, neither chasing nor fleeing. You imagine the solar system as a great wheel, and these points, the Lagrange places, as spokes of stillness, where matter collects, not by chance, but by quiet alignment. What else might gather there, in these gentle eddies of gravity? Dust, ice, old spacecraft. Secrets of the early solar system preserved in motion. As you drift out of the Lagrange light, you feel the curved path of Earth beneath. Your feet, not a straight line, but a circle with companions, some of them unseen, and farther out, past even Mars. Another world orbits in near-perfect isolation, tilted and blue, its axis turned almost sideways. You find yourself far beyond the planets, beyond the orbits and rings and quiet moons. Here, the sun is barely a star, a pale ember in the distant dark. But even here, things move. A flicker appears, small, fast, ancient. A comet arcing in from the edge of the solar system, pulled from slumber by the gravity of the sun. It was born in the Oort cloud, a vast, invisible sphere of icy fragments that surrounds everything. A place where time has no rush, where orbits stretch across millions of years. And now, one of those frozen travelers has begun its fall. You drift beside it, close enough to see its surface. Not smooth, but jagged and black, a lump of ancient ice and dust, unchanged since the solar system's beginning. As it nears the inner system, sunlight awakens it. The ice sublimates, turning straight into gas. Jets burst from the surface, and a coma forms a glowing halo of mist, soft and brilliant. And then the tail, not one, but two. One of gas, pushed gently by solar wind. One of dust, trailing like a veil. They stretch for millions of kilometers, pointing always away from the sun. No matter where the comet flies, you watch this icy messenger race by, a memory in motion, older than any book, older than any name. It glows not with fire, but with freedom. Brief, breathtaking freedom, and then it begins to fade. The warmth recedes, the tails vanish, the glow dims, the comet returns to the cold, carving a lonely arc back into the dark. It may not return for 10,000 years, or 1,000,000. Some. Never do you watch it shrink, not with sorrow, but with awe. To move so far, and still find your way home, what patience lives in such an orbit? The comet disappears beyond sight, its path like a long inhale, waiting to exhale again, far, far in the future. And now, your gaze turns inward once more, to a planet tilted oddly, rolling on its side like a sleeper turning in space. You drift into a soft, blue silence. The stars dim behind a haze of pale cyan, and before you rises Uranus, a planet unlike any other dot. It doesn't stand upright like the rest. It leans sideways, its axis tipped nearly 98 degrees, as if it once fell over and simply chose to stay that way. You float above it, watching rings spin vertically, circling like a hula hoop around a resting dreamer. Its north and south poles aren't like Earth's. They take turns facing the sun directly. Each season lasting 21 years, one pole bathes in sunlight for decades, while the other rests in shadow, and then they switch. A planetary breath so slow you can barely feel it move. Why does Uranus spin this way? No one knows for sure. But most believe it was struck by something massive, a collision in the early solar system that knocked it sideways, leaving it rolling rather than turning. And yet it moves with grace. You watch its pale blue clouds, icy methane swirls, beneath soft layers of gas. There are storms here, winds over 500 miles per hour, but they whisper through the upper atmosphere without drama, without sound. You drift through its delicate ring system, thin and dark, almost invisible in the dim sunlight. The rings aren't bright like Saturn's, but they shimmer faintly, dust and stone held in place by Uranus's tilted pull. You glance at its many moons, Miranda, twisted and patchworked like puzzle pieces, aerial, gleaming with fractures and frozen canyons. All of them follow Uranus's sideways path, orbiting along the same strange plane. This tilted world doesn't resist what happened. It doesn't struggle to stand. It simply rolls, slow and sure, turning imbalance into rhythm. You hover at the edge of it all, feeling the long shadow cast by a world that keeps moving even when off-center. And just beyond Uranus, another giant waits, more distant, deeper blue, with storms that have lasted for centuries and winds that race faster than sound. You're not just spinning round the sun, you're part of a great journey around the galaxy. It takes 225 million years to make one full circle. Even now, you're sailing through the stars. You drift farther now, beyond the edge of any one planet, past the pull of any single world. You rise until the solar system becomes a shape, a swirl of light, a dance of orbits held in delicate balance. But then, something larger reveals itself, a motion so vast, so slow, you don't feel it. And yet, you are part of it. The sun, that glowing center you've always circled, is itself moving. It orbits the center of the Milky Way galaxy, carrying everything with it: planets, moons, comets, light, and you. One full orbit around the galaxy takes about 225 million years. A galactic year. The last time the solar system was here, dinosaurs were just beginning to walk the Earth. You are moving now, even as you sleep, at nearly 828,000 kilometers per hour, racing through interstellar space, looping around a dense, star-packed center you cannot see. You picture the Milky Way, a spiral of stars, its arms curving like wind-blown silk. Our sun drifts in one of those arms, the Orion Arm, a small river of stars in a galactic sea. But this orbit is not a circle drawn in ink. It wobbles, rises, and dips through the plane of the galaxy, as if the solar system is bobbing gently on. Waves of dark matter and time. You imagine the journey not in years, but in generations, entire species rising and vanishing before one full orbit is complete. Civilizations flicker, and still the stars keep turning. Even the sky changes over deep time. The constellations you know today will warp and stretch, their patterns drifting as the sun sails on. And yet, you feel no rush. The motion is so wide, so slow it becomes a comfort, like a deep breath held across an age. You look around at your traveling companions, every planet, every moon, even the Oort clouds, silent watchers. They are all part of this voyage, sailing with you through the galaxy's dark sea. And just ahead, on the outskirts of this solar ship, there is a cold, distant world whose path defies even our best maps. You drift now to the edge of the known. Giants, where the sun is little more than a pale memory. Here spins Neptune, slow and dignified, wearing a robe of blue and green, streaked with icy clouds that never sleep. This is a place where time stretches out like breath. A single year on Neptune, one full orbit around the sun, lasts 165 Earth years. A lifetime for you is just one circle for it. You glide beside it, feeling the immense quiet of distance. There's no rush here, no ticking of clocks, only slow spirals of light and dark, seasons that last for decades. And yet, Neptune moves quickly. In other ways, its winds are the fastest in the solar system, racing at more than 2,000 kilometers per hour, slicing across methane-rich clouds that swirl in cold grace. Beneath those clouds, layers of gas compress into icy fluid, and farther still, a rocky core waits in silence, but no one has touched it. No probe has landed. Neptune keeps its heart hidden. You pass a storm, a dark oval like Jupiter's red spot, but colder, quieter, a place where atmosphere sinks, spinning in shadows. The planet tips slightly as it spins, just enough to create seasons. But on Neptune, a season lasts 40 years. Summer and winter arrive like slow waves, rolling through time instead of weather. You wonder how long Neptune has turned like this. What was happening on Earth when it last passed this way? And who will watch it when it returns to this point again? You float in the blue hush of Neptune's orbit, feeling the patience of a world that measures its lifeline centuries and just beyond. Where the sun's pull begins to waver, there may be something else, something unseen, something heavy, a world that doesn't shine, but tugs. Ge begins. You are in the Kuiper Belt, a place of icy leftovers, where dwarf planets drift like forgotten ideas. Pluto is here, yes, small, tilted, distant, but something else may be nearby. Something big, something we haven't seen. Astronomers call it Planet 9, a hypothetical world that might explain the odd orbits of objects at the edge of the solar system. These distant bodies move in strange patterns, as if being pulled by something. Heavy in the shadows, you drift into the dark, past the last of the known. Here, space feels wider, colder. Even the stars seem farther apart. You imagine Planet 9, a world perhaps 10 times more massive than Earth, orbiting so far away that its year could last 20,000 Earth years. It wouldn't reflect much sunlight. It would glow faintly in infrared, a warm whisper against the black. But we haven't found it. We search the sky with wide eyes, our telescopes scanning for motion, for a tiny shift in the stars that reveals a giant's path, and still it hides. If it exists at all, it may be tilted, elliptical, moving slowly through a realm we barely touch, yet its effects are there, like the wind moving grass, even when the wind itself is unseen. It tugs on Pluto, on Eris, on Sedna. It reshapes the edges of the solar system's map. You float in this quiet place, imagining a world that no one has seen but many believe in. A mystery built from math, a ghost revealed by gravity, and beyond even this mystery, beyond the numbers and theories, lies a red planet, one we know well, one that holds dust and sky, and a mountain so high its peak touches the edge of space. Olympus Mons rises like a god's forgotten mountain, 3 times taller than Everest, wide as a country. You climb it in your mind, where the sky darkens and gravity falls away. Now you turn toward the red world, dusty and quiet, with valleys like scars and skies tinted with rust. This is Mars, a planet of echoes and ice, and at its heart rises something vast. Olympus Mons, a volcano so tall it pierces the edge of the atmosphere, 3 times taller than Mount Everest, 624 kilometers wide, larger than some countries. You drift beside it, hovering near the caldera, a collapsed summit the size of a city. From here, the curve of the planet itself bends beneath it. Olympus Mons is so massive that its base follows the curvature of Mars. It is not a mountain, it is a world within a world. It formed slowly, not in explosions, but in lava flows, spilling over centuries, layer upon layer, in a place where gravity is. Light and tectonic plates do not shift. On Earth, a volcano moves with the crust. But on Mars, it stayed in one place, erupting again and again, building a tower of time. You float downward, gliding over cliffs and ridges, tracing the trails of long-cooled rivers of fire. It has not erupted in millions of years, but you can still feel the heat in memory that at the summit, the sky is darker, not from weather, but from height. You are so high, even the thin Martian air begins to fade. Only the stars remain, quiet and constant. You imagine standing here, gravity pulling gently at your feet, your breath slow, your body small beneath the ancient dome of space. Mars may seem quiet now, but its volcanoes speak of a past when the planet stirred, when it breathed fire and built giants, and far to the south, beneath the ice caps and dust, another mystery rests. Not a volcano, but a crater. Dark and round, you return now to the center of it all, to the light that holds the solar system together. The sun, steady and golden, breathing light into every world it touches. It feels eternal, unchanging. But even stars have lifespans, right? Now, our sun is in its middle age, calm, bright, balanced. Its gravity holds the planets in orbit, its warmth nourishes Earth's air, and its light paints the days. But time flows slowly for stars, and in the distant future, billions of years from now, this familiar sun will begin to change. It will run low on hydrogen fuel, its core shrinking, its outer layers swelling outward like a breath held too long. The sun will become a red giant. Its surface will expand, spilling into the orbits of Mercury, Venus, and maybe even Earth. You float in that future now, watching as the one Cielo star turns red and wide, a swollen, glowing ember of its former self. The Earth, if not swallowed completely, will burn. Oceans will boil. The sky will vanish. And yet, it is not destruction alone. This is a transformation. A star letting go of one life to become something new. After shedding its outer shell, what remains is a white dwarf, a hot, dense pearl of starlight, cooling slowly over trillions of years. A star's final whisper. You drift near it now, a tiny sun, no longer shining with fire, but glowing softly with memory. It's a reminder that even the brightest things you know are part of cycles. Creation, flame, ash, the solar system will look different then. Perhaps new worlds will form. Perhaps others will drift on. You look back once more at that familiar light, changed, ancient, still beautiful. And then you turn toward something lighter, stranger, a moon that doesn't glow but bounces. Hyperion is no sphere, it's a porous, tumbling sponge. Low gravity keeps it jagged, light, and strange. You land softly on its surface and bounce into the void again. Now you arrive at Hyperion, a moon that doesn't spin like the others, doesn't shine, doesn't sleep. It tumbles chaotically like a leaf caught in the wind. It's one of Saturn's stranger moons, not round, not smooth. Instead, it looks like a sponge, full of holes, as if someone carved it from soft stone and forgot to finish. You drift toward its surface. There's no sound here, only the hum of your own breath and the slow rotation of stars above. Hyperion's gravity is weak, just enough to hold it together. Its porous body means you could leap gently, land, and bounce again as if the whole moon were made of foam. Its craters are deep, sharp-edged, yet dry and ancient. No atmosphere smooths them over. No wind erases time. They remain open, like memory. Scientists believe Hyperion is a rubble pile, loosely held fragments left over from collisions never pressed into a sphere by pressure. A relic, not of ruin, but of slow formation, and it tumbles unpredictably. Its rotation not fixed, its motion never repeating. You can't predict what part of it will face the sun, or when its dark side will greet you again. You reach out, press your hand gently to the surface, and feel it give slightly, not soft, but not solid either. Like ancient snow pressed together, then left for eons to drift alone. You bounce upward, lifting slowly in the low pull, watching the odd world shrink beneath you. It doesn't feel dead. It feels timeless, suspended, even here, in the quietest corners. The solar system offers shape and motion you couldn't imagine until you saw it. And as you float onward, leaving the sponge moon behind, you catch a whisper of vibration, a tremor, far from Saturn, but much closer to home. You lie on lunar soil and feel the echo, a reminder that nothing is truly still. You return now to Earth's companion, the moon, so familiar, so quiet, a pearl in the dark that seems to never change. But beneath its still face, there are stirrings. You land softly, dust rising around you in slow arcs. The moon's gravity is light, the sky above always black. No wind, no sound, only silence and movement, because even here there are moonquakes. Some come from thermal stress, as sunlight warms the crust and night cools it down. The temperature swings are brutal, and the surface contracts and expands, creating gentle pops beneath the dust. Others come from deep within, quakes that last for hours, triggered by tidal pulls as Earth's gravity stretches the moon's interior again and again. Not enough to break it, just enough to shake it. And some quakes are caused by the ancient wounds of meteor strikes, echoing across hollow chambers, still ringing like a bell centuries later. You lie back now, on cool regolith, your body still, your ears pressed to nothing, and yet you feel it. A gentle tremble, like the moon remembering something. Seismometers left by astronauts have recorded it, a living stillness, not from life, but from memory. From motion the moon may seem frozen, but beneath its dust it shifts, breathes, waits. You rise again, lifting gently off the surface, carrying with you the realization that even silence can move. And now you turn toward Jupiter and its wildest moon, where silence is replaced by fire. You've drifted far from the gentle tremble of the moon. Now you arrive at Io, a moon of Jupiter, but nothing like any place you've seen before. It is not quiet. It is not calm. It is alive with fire beneath. Jupiter's immense gravity, Io is pulled and stretched like taffy. This constant tidal flexing creates intense friction inside, melting its interior into a sea of molten rock. You float above its surface, and below you, lava lakes bubble and churn, fountains of fire leap skyward, eruptions paint new land in real time. The surface is a wild mosaic, yellow sulfur plains, red scars, black glassy flows, still cooling. Io is the most volcanically active body in the solar system, more than Earth, more than anywhere. Its volcanoes don't sleep, they spin and pulse, spitting heat into the frozen void. Some eruptions stretch hundreds of kilometers high, plumes of ash and gas rising above the moon's paper-thin sky. There's no air to stop them, no winds to carry them. They simply rise and fall in silence. You hover over a lava lake. It glows orange, then gold, like a heartbeat deep beneath stone. You feel it, the planet breathing fire into cold space, and above, Jupiter watches, a giant wrapped in storms. Its presence so massive it shapes the lives of its moons. Io doesn't orbit gently. It is locked in gravitational games with Europa and Ganymede, pushed and pulled, never still. This stress, this tension, is what fuels the fire. Without it, Io would cool, harden, fall silent. But instead, it rages on. You float just above the glowing crust, watching new land be born from beneath your feet. The sky is black, the ground is red, and everything is in motion. This is not destruction. This is creation in its rawest form, heat rising from ancient stone, light spilling from deep time, and as you rise away from the heat, leaving Io in its volcanic song, your gaze turns to something quieter, a pale ring of rocks, stretching across a giant planet's waste, like a whisper of frozen time. The outer atmosphere of the sun burns hotter than the surface below, a mystery of energy, rising like a flame that defies its origin. You float in the bright mist, feeling heat without touching fire. You return again to the sun, but not to its core, not to the surface, but to something even stranger. Here is the corona, the sun's outer atmosphere, glowing like a pale halo during a solar eclipse. It seems faint, thin, fragile, and yet it is hotter than the surface beneath. The sun's surface, the photosphere, burns at around 5,500 degrees Celsius. But this corona, this glowing mist, can reach over 1,000,000 degrees. A mystery, a contradiction, a flame hotter than its own heart. You drift through it carefully, watching loops of plasma arch upward in great sweeping bridges of fire. These loops follow magnetic fields, invisible threads twisting and snapping as energy surges from deep within. No one fully understands why the corona burns so bright, so hot. It may be the work of magnetic storms, tiny nanofleurs that unleash massive energy in brief, chaotic bursts, or perhaps it's something deeper, a secret in the sun's breath, carried upward by waves that rise and do not cool as you float here. The heat passes around you, not like fire, but I like the vibration. It tingles your thoughts, a warmth without touch. This is where solar wind is born. Particles cast off like whispers, racing outward into space. It touches every planet. It shapes comet tails. It creates auroras that dance above Earth. You watch. This wind leave the corona, traveling far, faster than sound, carrying the sun's energy to the edge of the solar system. Even in this brilliance, The corona fades into darkness, its edges dissolving into cosmic night. And beyond it, far away, a blue giant waits, where wind has a different meaning. The coldest giant blows the fastest winds. Storms howl faster than sound across ghostly blue clouds. You sail through this whispering chaos, wrapped in frozen speed and silence. You travel now to Neptune again, but not to admire its colors or calm. This time, you listen. You listen for something you cannot hear. The wind on Neptune, the winds blow faster than anywhere else in the solar system. Faster than any hurricane on Earth. Faster than the speed of sound, 2,100 kilometers per hour, winds that would tear cities from their roots, rip oceans into vapor. But here, there is no ocean, no forest, no buildings to resist, only clouds, faint blue and white, made of methane and icy gases, racing each other endlessly around a planet far too cold for storms to thrive. And yet, they do. You drift into the upper atmosphere, where storms swirl like ghostly wheels. You see the faint blur of a great dark spot, a storm the size of Earth, silent in the blue. It fades and reforms, never the same, always moving. How can such a cold planet have such furious winds? Scientists still wonder. Perhaps it's heat from within, a hidden furnace beneath icy clouds, fueling motion no sunlight could sustain. Or perhaps it's Neptune's rotation, fast, tight, whipping the atmosphere into narrow belts of velocity and swirl. You don't hear the wind. There's no air to carry it to your ears, but you see its shape in the clouds. You feel it in your thoughts, as if the planet breathes motion into space. And then you ride it. Let yourself be carried a leaf in Neptune's endless gust, spiraling into the quiet beyond. The winds fade as you rise, leaving behind the blur of cold hurricanes. And ahead, beneath a red sky, dust begins to dance. Not here, but far away, on a dry, rust-colored planet, where whirlwinds twirl in silence. Little tornadoes dance across rusty deserts. They swirl like spirits over silent plains. You walk with one as it traces invisible paths, its presence felt more than seen. You touch down on Mars again, this time not for mountains or ice, but for something smaller, lighter, a dance of air and dust. You don't hear it at first. There's no wind in your ears. Just a faint shimmer on the horizon, a swirling thread of rising sand, a dust devil. It spirals upward, thin, transparent, a ghost lifting the Martian soil into a tower of light. These aren't storms like on Earth. They don't flash or rage. They whisper, they twirl. Some stretch a mile high, but only a few meters wide. Tall, narrow spires of motion, spinning across the plains in silence. Mars is dry and cold, but during the day, the ground warms just enough to stir the thin air into a rising spiral. That spiral pulls dust upward, carving delicate paths through the desert. You walk beside one now. The dust tickles your suit, clinging in streaks of red. The sky above is soft pink, muted by the haze, and the devil twirls beside you like a dancer without feet, moving in random, graceful curves. The rovers have seen them too. They pass over cameras, casting shadows, cleaning solar panels with sudden gusts. Even in this stillness, the planet breathes. It remembers motion. It carries heat upward in spirals, writes poetry in particles. You pause, watching one trail away from you. It leaves no mark, but you feel it as if it passed through your thoughts. The surface stills again, calm and dry, and in the shadow of a nearby crater, you sense something colder, not above, But below, in darkness, untouched by day, on a planet so close to the sun, you'd think ice could never exist. The closest planet to the sun hides frost in the dark. Deep craters never see light, and within, ancient ice rests. You kneel beside frozen water where you'd expect only fire. Now you drift inward, to the first planet from the sun, Mercury, a world of extremes. Daylight burns, nighttime freezes, and in between, silence reigns. You expect heat here. After all, Mercury is scorched by sunlight, its surface reaching 430 degrees Celsius during the day. But not all of Mercury sees the sun. There are places, craters at the poles so deep and angled the sunlight never enters. These shadows are eternal. They lie in permanent darkness, untouched by warmth for billions of years. And within them, a secret gleams. Ice. Yes, on Mercury, frozen water gathered from comets and solar wind, preserved in blackened bowls of rock. You descend into one of these craters. The sunlight stops above you. The temperature drops. It feels like stepping into forgotten time. Your feet land softly beside frost, pale, still, ancient. The ice here is not from recent rain. It is a fossil, a record of water's visit to the innermost planet. Scientists detected it by radar, bright reflections in shadowed pits, proof of water in the hottest neighborhood of the solar system. It survives because of shade, because of cold traps that hold it tight, away from the sun's breath, and you kneel beside it, realizing that even here, where fire should reign, stillness preserves cold. You trace your fingers above the frost, not touching, just feeling the presence of contrast, heat and ice, light and dark, and beneath the ground, beyond your senses, the planet trembles with old echoes. But above the heat and cold, in the burning atmosphere of the sun itself, a quieter sound calls to you, not heat this time, but music. Though you cannot hear it, the sun hums. Its surface ripples with sound, pressure waves in burning gas. You tune your breath to its frequency, and the universe sings softly back. You return one last time to the sun, not to feel its fire, but to listen. And though you have no ears for it, no air between you to carry the sound, still, the sun sings. Its surface ripples, waves moving through hot gas, vibrating like a drum the size of 1,000,000 Earths. These are not sounds like voices or flutes. These are pressure waves, vibrating through plasma, the fourth state of matter, where atoms drift like glowing dust. You float above the photosphere, watching tiny oscillations, 5-minute pulses that lift and fall as if the sun were breathing. And in a way, it is. This field of study has a name: helioseismology, the science of listening to a star. By studying these waves, we've learned what lies beneath the surface, how the sun's inner layers rotate, how heat rises, how magnetic fields twist and burst. Each wave carries a clue. Each ripple is a message, not for your ears, but for your understanding. And still, you feel it. A kind of cosmic harmony, resonance moving through silence. If you could slow it down, translate the language of fire into melody, you would hear the sun's hum, a deep tone, a slow chant, a lullaby of light and gravity. You breathe with it, not in lungs, but in thought, your imagination aligned to the rhythm of a star. Even now, this sound travels outward, waves in solar wind, ripples in magnetic fields, echoes of a living, pulsing core. The sun is not silent. It just sings in ways we must learn to feel. You drift back slowly, your body calm. Your mind is quieted by the warmth and vibration of starlight, and as the waves fade, you turn once more toward the deep, where silence becomes icy again, and gravity becomes curious. Beneath serene blue clouds, sulfur drifts. Invisible molecules give the planet a sharp sting. You float through the skies of Uranus, where beauty hides a sour truth. You arrive at Uranus, a pale, powdery blue hanging quietly in the dark. It looks peaceful, still. But here, as always, stillness can be deceiving. You drift into the upper atmosphere. The wind is quiet, the sunlight weak, filtered through distance and haze. Uranus spins on its side, tilted like a dream out of alignment. Its seasons last decades, its poles spend years in darkness, and the sunlight never truly warms its bones. You move deeper, through layers of cloud, hydrogen, helium, and something else. Hydrogen sulfide, the same gas that rises from rotten eggs, from volcanoes, from deep ocean vents on Earth. You can't smell it here, not through your visor, not in this vacuum. But you know it's there. Invisible molecules drift upward from the planet's cold clouds, and if you could breathe this air, you'd recoil at the sting. Why is it here? Because Uranus is strange. Its atmosphere holds secrets that other giants bury deep, while Jupiter and Saturn cloak their sulfur low. Uranus wears its sharpness near the top, a bitter perfume above the silence. You hover, watching pale storms churn slowly, shapes melting into each other like watercolor. This is not a violent world, not like Jupiter, not like Neptune, but it is distant, and its distance makes it quiet. And beneath the beauty, beneath the soft blues and quiet turns, there is always more, always contrast. Even here, on a world that seems cold and empty, there are stories of chemistry, of gas and shadow, of smells that speak. And as you rise above the clouds again, you think of places once full of water, now full of memory, a world not as far as this, but dry all the same, once wet, now waiting. Carved channels tell a story of ancient water. Mars, once wet, now dry, its rivers frozen in memory. You trace old riverbeds with your thoughts, listening for the drip of a vanished world. You step onto Mars again, but not for dust devils or volcanoes. This time you seek something deeper, a memory of water. The ground is cracked, etched with patterns that whisper, "This was once a river." There are valleys here, as wide as Earth's greatest canyons, winding and bending like streams that no longer flow. You follow one. A dry path curves between hills, softly sloped like the sides of a stream. Pebbles lie scattered, as if they were once smoothed by current. There are deltas too, fans of sediment, spread gently where rivers met still lakes. A quiet geometry of erosion and deposition, preserved in stillness. Billions of years ago, water flowed here, liquid water. Rain may have fallen, lakes may have rippled in the sun, and somewhere, perhaps, life may have listened. You kneel in a dry channel, placing your hand on cool stone. It remembers the river, even if the river is gone. Rocks tell stories in silence. Minerals shaped by water, clays, salts, patterns, too precise to be chance. And the orbiters above, they map these scars from space. They trace riverbeds that stretch for hundreds of miles, evidence of a climate that once breathed. Why did it stop? Perhaps the air thinned, perhaps the magnetic field faded, perhaps the warmth drifted away. Mars lost its sky, and with it, its water now, The rivers are shadows, fossils painted onto landscapes of red dust and soft wind, but you still see them. In every curve and channel, in every slope and layer, you see the trace of motion, the dream of flow. And as you rise above the valley, looking down on a planet of dried veins, you glimpse something in the distance, not a canyon this time, but a ring, not Mars, but Jupiter, and around it, a ghostly shimmer. Faint and ghost-like, a hidden halo circles the giant. Not like Saturn's brilliance, but subtle, quiet, soft. You catch a glimpse through shadow, where dust becomes light for a moment. You've seen Saturn's rings, bright, wide, icy, a spectacle of reflection and symmetry. But now you float near Jupiter, and at first you see nothing. Only clouds, only storms. But look again in the shadows. Just beyond the glare of the planet, a faint glow appears. A ring not of brightness, but of quiet dust. Jupiter has rings too. They're not made of ice, they're made of tiny particles, ground down from moons and carried upward by impact. They don't shine, they scatter light like mist. They are harder to find, easier to lose. But here, in the right angle, you see them. A whisper of structure around a roaring planet. The main ring is narrow, delicate, fed by Jupiter's tiny moon, Metis. A quiet body, constantly bombarded. Its dust flung upward into orbit. There are halo rings too, closer in, and gossamer rings. Farther out, thin veils nearly invisible. These rings are not for show. They don't demand attention. They exist like memory, present, but only visible when you're still enough to see. You fly through them slowly. Dust flickers past you, like stars. They hold no weight, but they speak of motion, of cycles, of impacts and reformation. Everything that orbits wears a story, even the dust. You turn back to Jupiter, its storms still raging, its moons still circling. The planet roars, but the rings, they whisper. And as you drift outward again, the quiet follows you. You feel your direction shift, not just in space, but in spin. A planet turns strangely in the distance, its clouds thick and glowing, its rotation reversed. Backwards it turns, unlike almost everything else. The sun rises in the west and sets in the east. You drift over its glowing clouds, where time and direction both feel reversed. Now you reach Venus, the morning star, the evening star, a twin of Earth, but only in shape. It turns backwards. Almost every planet in the solar system spins the same way. But not Venus. Here, the sun rises in the west and sets in the east. Its rotation is slow and opposite. One day on Venus is longer than its year. A world of reversal, of slow fire, of soft, crushing pressure. You hover above its clouds, a thick blanket of sulfuric acid, glowing yellow and pale white. You don't see the surface. You can't, but you feel the difference. The planet spins, slowly, but its atmosphere moves fast. Rotation, clouds whipping around the globe in just a few Earth days. The air turns the other way. A dance of contradiction. Why does Venus spin this way? Perhaps a great collision turned it. Perhaps it simply drifted into this rhythm over time. No one knows for sure, but the result is clear. Venus is alien, even though it looks familiar from afar. You watch the sunlight move backward, casting long shadows in the wrong direction, and the feeling grows that you are upside down in time. Even its geology resists normal patterns. The surface is young, yet shaped by ancient forces. It is both new and old, both active and hidden. You rise again, leaving the thick clouds behind, and catch a glimpse of the moon, not Venus's moon, for it has none, but Earth's own companion, always turning, always looking at us, and yet never showing its back. No matter where you stand on Earth, the moon keeps one side hidden. It turns just enough to never turn away. You stare into its steady gaze, while the far side dreams alone. You look up again. The moon is there, as it always is. But did you ever notice it shows you only one face? No matter the phase, no matter the time, you see the same craters, the same seas, the same familiar shape. This is not a trick, it's a truth. The moon is tidally locked to Earth. It rotates once on its axis in the same time it takes to orbit us, about 27 days. That balance means one side always faces us. It turns, but not away. The near side is marked by Maria, dark plains of cooled lava smeared across ancient stone. You know this face, the man in the moon, the rabbit. The stories passed down from every culture on Earth. But the far side, it's different. More craters. No Maria, more scars, less smoothness. It remained a mystery until spacecraft circled it. No one had ever seen it, not directly, not from Earth, and even now it feels lonely. You imagine standing there on the moon's far side, Earth out of view, the stars are quiet. A view humans were never meant to have, but found anyway. The moon turns, but always keeps its secret. Always half known, half unknown. You float between both faces, the familiar and the hidden. And just beyond, you see Saturn, not just the planet. It rings, vast, glorious. But something is changing. Bit by bit, the rings are falling in. Ice becomes vapor, dust becomes rain. You watch as centuries pass in seconds, and a masterpiece fades quietly into memory. You return to Saturn, not to orbit, not to glide through its icy rings, but to watch something vanish. At first, it doesn't seem possible. The rings are vast, so bright, so wide, stretching out hundreds of thousands of kilometers. A crown of brilliance around the gas giant dot. But even the most beautiful things do not last forever. You drift above the equator, where the rings shine brightest. Tiny particles, chunks of ice, flecks of dust, dancing in perfect orbits. But now, some of that dust begins to fall. Drawn in by gravity, pulled by Saturn's magnetic field, the rings are slowly raining down. Ring rain, scientists call it, invisible to the eye, yet measurable, a drizzle of particles, streaming into the planet's atmosphere. 1 billion years from now, maybe less. These mighty rings may be gone. The water in the rings vaporizes when it hits the upper atmosphere, becoming part of Saturn itself. What was once structure becomes cloud. What was once spectacle becomes silence. Cassini saw this. Before it dove into the planet, it flew between the rings, measuring the fall, listening to the quiet collapse. You float now where that spacecraft once flew. Dust flickers past you, ancient shards of moonlets, collisions frozen in time. These rings may have formed when a moon wandered too close. Ripped apart by gravity, it shattered, and the fragments spread. They've circled ever since. A temporary monument to tidal forces and broken symmetry. And now, you witness the slow goodbye. You reach out, letting a sliver of ice brush your hand. It glows, soft and cold, before it begins to fall. You don't stop it. You can't. The universe is full of beauty, but also change. Nothing remains unchanged forever. You rise again, looking down one last time at Saturn's glowing crown, still here, still grand, but already beginning to fade. And just as it falls, you drift further out to a world of blinking lights, where alien skies flicker with electric blue, a moon, distant and strange, where lightning dances through methane clouds. A swirling shadow floats across blue clouds, like Jupiter's red storm, but darker, colder, quieter. You watch it drift like a bruise in the sky, a storm with no thunder, only presence. You arrive at the edge. Here, in the dark cold of the outer solar system, Neptune turns quietly. Its clouds swirl in ice-blue ribbons, and deeper still, something darker stirs. A storm, not red like Jupiter's, but deep and dark, almost black against the turquoise sky. A bruise upon a frozen world. It is called the Great Dark Spot, though sometimes it vanishes, sometimes it shifts. A storm that comes and goes, like memory. You hover above it, watching clouds whirl in silence. It is massive, as wide as Earth itself, and though you hear no wind, you know they howl at supersonic speeds. The fastest winds in the solar system tear across Neptune's sky, yet everything here feels slow, muted, distant, heavy with blue. This storm is not made of water. It is methane and ice, frozen gases swirling in low light, and while Jupiter's great red spot rages with fire and depth, Neptune's shadow moves like fog, dissolving over time, then forming again. Scientists first saw it in 1989, a passing moment in Voyager's eye. Since then, it has come and gone, like a ghost returning to the same room. You drift closer. The edge of the vortex curls downward, revealing nothing, just layers of atmosphere, cold and deep and quiet. What lives in storms like this? Not creatures, but questions about how wind behaves without warmth, about how storms rise in a world without sunlight, and still Neptune spins. Its storm remains, darkness against color, motion without noise. You float above it, watching the spiral, until something flickers in your thoughts. Light, a thin line of it. Falling, you turn, and across the vastness of space, you see Earth. Not the planet, but the sky above it. Something glowing, moving through the dark like a wish. You make wishes on shooting stars, but they're dust, ancient crumbs from icy wanderers. You sleep under a sky full of cosmic leftovers, falling gently into our world. You lie on your back, wrapped in darkness, beneath the great dome of Earth's sky. A flash, then another, shooting stars, but these are not stars, they are dust. Tiny flecks of ancient comets, burning bright as they fall. Every year Earth sweeps through trails of it, comet crumbs left behind on long, icy orbits. The Perseids, the Leonids, the Geminids, named for constellations they seem to pour from. They arrive like scheduled whispers of space. You float upward in thought, rising above the atmosphere, watching as the planet plows through invisible rivers of dust, each speck no bigger than a grain of sand, yet moving so fast, tens of thousands of kilometers per hour, that when they strike our air, they burn, brief and bright. These flashes are memories, pieces of comets that circled the sun before we learned to name time. Some come from the Oort cloud, so far away it is almost myth. Some from the Kuiper belt, where icy bodies slumber, occasionally nudged inward by the gravity of passing giants, and when they do, they begin to melt. Their tails lengthen, their trails stretch, and Earth, in its orbit, finds those trails again and again. You fall back to the ground, listening to nothing. There is no sound to these meteors, only light. Some streak long and white, some flare green, or leave glowing trails. And now and then, a fireball, bright enough to cast shadows. People make wishes. You do too. Even knowing what they are, you still whisper hope into their fleeting light. For a moment, you feel part of it, the long orbit of a forgotten comet, the dust of a trail older than civilization, the heat of an atmosphere that turns memory into spark, and in that spark, you wonder what sunsets must look like on planets with thinner skies. You imagine Mars, red, dry, but under the right light. Soft, the red planet saves its gentlest color for the end of day. As the dust settles, the sun dips into cool sapphire light. You sit on a quiet hilltop, watching blue hush the crimson. You return to Mars, this time, at evening dot. The sky is peach and rust. The land glows in soft, warm red. But something strange begins to happen as the sun draws low, on Earth. Sunsets are fiery reds and oranges, painted by thick air and water vapor. But here, on this dry, thin world, the colors reverse. The sun slips lower, and the dust, the very dust that colors Martian skies during the day, begins to scatter the blue dot. It isn't bright. It isn't loud, but there it is, a cool halo around the setting sun. Sapphire, pale, soft dot. You sit on a gentle hill, feet planted in fine dust, watching the colors invert. The air is too thin to breathe, but your eyes drink it in. Scientists once puzzled over this, until they understood. On Mars, fine dust filters the light differently. It lets bluer wavelengths pass through at sunset, while on Earth, blue is scattered away. So Mars, red by day, turns blue at dusk. You find peace in that reversal. A planet known for fire and war reveals its gentler side in the quiet of evening. You trace the horizon with your gaze. Mountains far away fade into blue haze. Craters fill with shadow, and the sun, smaller here, more distant, finally vanishes. A few stars emerge. Phobos rises first, a swift moon already racing across the sky. Then Deimos, smaller, quieter, barely more than a dot night on Mars, is colder than ice. But in this moment, with the blue fading slowly, you feel something warm in the calmness. Of it all, the sky deepens. The world sighs, and somewhere, beneath that cooling dust, a crystal waits in silence, left behind by an ancient ocean. Beneath ice, oceans wait. Europa, Enceladus, Titan, they hold more water than we do. You float over frozen shells, imagining the life that might dream below. You leave the dry red of Mars and drift outward, where warmth fades, but something else waits. Not heat, but depth. Europa, a moon of Jupiter, shines like a marble wrapped in cracks, white, streaked, as if something beneath had tried to speak, and perhaps it has. Below this frozen skin is a vast, global ocean, salt water, liquid, moving, heated not by sunlight, but by the tug of gravity. Jupiter pulls, and Europa flexes, and deep within, the ice melts. You imagine standing on its surface, listening to distant creaks, as if the moon itself were breathing slowly. Then further, out Enceladus, a moon of Saturn, smaller, colder, but alive. It shoots geysers of water into space, plumes so strong they feed Saturn's rings. You drift through one. It's fine and cold and full of salt. And inside, scientists have found hints of organic molecules, building blocks of life. Water, water, everywhere, even when no one expected it. And then there's Titan, stranger still. It has rivers and lakes, but not of water. Its seas are made of liquid methane, and yet beneath that icy crust, there may be water, too warm, hidden, and vast. Together, these moons hold more liquid water than Earth, not just ponds, but oceans, and where there's water, there could be life. Not fish, not forests, but perhaps something small, something strange, something that waits in the dark. You press your hand to the ice, not to break it, but to feel what waits beneath. And you wonder, could the story of life begin again, in places we've never walked? You rise slowly from the frozen plains, carrying questions like gentle waves inside you. And as you drift toward the center once more, you feel the weight of something far greater, a force that holds every orbit, every moon, every sea. Almost everything we orbit is one thing. The sun holds us all like gravity's great parent. You feel its pull, not just in your body, but in your story. It's easy to forget as you travel among planets, moons, dust, comets, how much of this entire system is made of one thing. The sun. It makes up 99.8% of all the mass in the solar system. Every rock, every gas giant, every icy pebble in the Kuiper belt combined cannot match it. You drift near now, not close enough to burn, but close enough to feel it. The pull, the warmth, the presence. Gravity bends around it like space itself is bowing. And you realize, we do not orbit the sun because of habit, but because we have to. Because the sun is the anchor, the rhythm, the great center of it all. It holds planets like pearls on invisible strings, keeps comets in long, looping paths, shapes everything. Without it, the planets would not spiral. They would fly away into the quiet dark. The sun feeds, it sings. It pulses with fusion, turning hydrogen into helium, mass into light. That light takes 8 minutes to reach you. By the time you see the sunrise, the moment is already memory, and still we circle. Earth with its oceans, Mars with its dust, Jupiter with its storms, all held by this ancient weight. You feel its presence, not just in motion, but in metaphor. The sun is gravity's parent, the hearth of the system, the reason the story holds together. Even the smallest grains follow its pull. And in this awareness, you listen for tremors, for a beat beneath the glow, a ripple in the brightness that suggests the sun itself might move. Solar flares ripple across its face, deep waves in light itself. The sun shakes, sings, shudders, then calms again. You rest inside a quiet moment, while distant tremors echo in fire. You hover just above the sun now, in a space of light and force, where silence meets fury, and then something shifts. A solar flare erupts, sudden, brilliant, a crackle of energy, thrown into space, but beneath that flare, something deeper happens. The surface shakes, not like an earthquake on Earth, but a sunquake. Waves ripple outward through the plasma sea, concentric circles in molten light. You can't hear them, but they exist. Waves of compression, born from a violent release, shaking the very surface of the star. It's as if the sun is speaking through shivers. These quakes aren't small. They travel thousands of kilometers across the photosphere. They echo for hours, like a bell still ringing long after it's been struck. You drift above the trembling face, watching rings expand in slow, radiant motion. Scientists trace them like whispers, measuring the sun's hidden layers by how the waves bend and bounce. It is a kind of solar seismology, reading the inner story of a star through the ripples on its skin. And even in all this violence, there is rhythm, a pulse, a steady beat of energy that gives life, warms planets, pushes wind across space. You feel it like a low note in your chest. The sun is not still. It roars, yes, but it also resonates. And as the quake fades, the surface softens. The rings blur and vanish. Peace returns. You float there, just above the memory of motion, and you wonder if the sun can shake with such light. What else in the cosmos vibrates quietly, singing songs we haven't yet learned to hear? Once, a star exploded. Its ashes became planets, moons, oceans, and you are made of borrowed stardust, sleeping in a galaxy of inheritance. Before the sun, before Earth, before names, there was a star. Large, brilliant, nearing the end of its life. It pulsed, it dimmed, and then it exploded, a supernova. The most powerful kind of ending, where death becomes the beginning of everything else. In that blast, the universe scattered elements too, heavy to form on their own: iron, gold, uranium, carbon. The building blocks of blood, of bone, of mountains and mines. You drift through that ancient cloud, ashes, glowing, shards of a star's final breath. Over time, millions of years, the cloud thickened, gravity gathered, swirls became centers. The sun was born, and around it, dust danced. Tiny grains collided, stuck, grew. Planets formed, moons formed, a system formed, and one small world, in the just right place, began to live. You come from this. Not just the Earth, but the cloud before it. You carry calcium from supernova fire, iron from that star's heart, oxygen forged in its final moments. Every atom in you was once part of something far larger. You are a story of inheritance. Even now, scientists find clues, isotopes in meteorites, unusual elements in old rocks that whisper, we came from something that once burned brighter than any sun. You float in this memory, feeling both small and wide. You wonder if one star's end could give rise to all this. How many other systems sleep in the remains of their own fallen giants? The night is not made of darkness, but of ancestry. And as you move outward, away from the sun, you see two small moons ahead, tumbling rocks around a red world. They are not round, they are not grand, but they, too, are made of stars. Not perfect. Spheres, but lumpy companions. Phobos and Deimos tumble awkwardly, like pebbles in orbit. You smile at their strange shapes, reminded that not everything graceful has to be smooth. You glide back toward Mars, and this time you look not at the planet but at the shadows nearby, Phobos and Deimos. Two tiny moons, not spheres, not shining orbs, but misshapen, like potatoes thrown into orbit. They're small. Phobos is only about 22 kilometers wide. Deimos, even smaller. Barely enough gravity to pull themselves into a round form. You drift alongside Phobos, watching its surface pass beneath you. Craters pick it like thumbprints. The largest Stickney crater takes up nearly half its body. A wound, a scar, a reminder of impact. It orbits so close to Mars, it rises and sets twice each Martian day. One day, it may even fall, pulled by the planet it circles. Deimos, further out, is gentler. It moves slowly, its path more distant, its pace is more patient. Neither moon was born here. Most likely they were captured asteroids, drawn in by Mars's gravity long ago, visitors who stayed, companions, though not symmetrical ones. You smile at their odd shapes, at how nature doesn't always make things smooth to make them beautiful. There is elegance in lopsidedness. There is a story about imperfection in their strange tumble. Phobos and Deimos remind you, you don't need to be grand to be part of something vast. You don't need to be round to be worth orbiting. You watch as they pass in silence, like skipping, stones frozen in time, and somewhere, far ahead, beyond Mars, a world waits, not rocky, not icy, but cloaked in cloud and spinning in reverse. The giant acts like a bodyguard, its gravity catching threats. You watch as icy intruders change course, their paths bent away by a planet's invisible shield. We are safer than we know. Out in the cold, past the asteroid belt, past Mars, you find Jupiter. It is immense, a world of swirling clouds, rings barely visible, and a magnetic field so wide it could swallow Earth many times over. But it is not just its size that matters. It is what Jupiter does, quietly, constantly, protectively, all around the solar system. Comets drift, ice and dust, some as old as the stars, some pulled in from distant reaches. Many move without aim, until they meet something large enough to change them. That something is often Jupiter. Its gravity is strong, so strong that it bends paths, alters orbits, pulls comets away from Earth. Sometimes it captures them, sometimes it hurls them back into the dark, sometimes it absorbs them completely, their icy bodies burning in Jupiter's clouds, like sparks in a storm. You hover now, watching one such traveler, a long cold tail behind it, rushing inward toward the warm center of the system, and then a shift. The curve of its path changes. It bends gracefully, drawn not toward Earth, but toward Jupiter. No sound, no flash, just a quiet rerouting in the great ballet of gravity. And you realize Jupiter is like a cosmic shield, standing between us and much of the danger that never even reaches our skies. We don't often think about it. We rarely see it. But it matters because space isn't empty, and protection doesn't always look like armor. Sometimes it looks like a gas giant sitting quietly on the edge, keeping watch. You turn now, looking back at Earth, small and blue and still spinning, and as the journey nears its end, you feel the pull not of gravity, but of wonder. So many things we've learned, so many more waiting. The facts are many, but the mysteries are more. Telescopes reach, rovers roll, and questions bloom. You close your eyes, knowing this bedtime story is only the beginning. You've wandered far, across planets and moons, past storms and silence, ice and fire. You've watched the sun tremble, seen Neptune's winds scream, touched glowing salt on Ceres, and slept beneath dust on Mars. You floated with potato-shaped moons, stood beside geysers that pierce the stars, and followed comets that return once in a million years. And still, you are only at the beginning. The solar system is mapped, but not truly known. We have names for its parts, but not all their stories. Telescopes reach, satellites orbit, rovers dig. They bring back data, yes, but also dreams. We send machines to ask the questions our bodies can't yet follow, but one day we might. One day. Someone may dive beneath Europa's ice and listen for life. Someone may climb Olympus, Mons, and watch a blue sunset from its peak. Someone may float above Saturn's fading rings just in time to see their final shimmer. We do not know when, but we know this: curiosity is a force as powerful as gravity. It pulls us forward, even in our sleep. You close your eyes now, not in ending, but in continuation, because the facts you've just wandered through are only the beginning of the questions. And the questions, they are endless. You breathe slowly, held by starlight, surrounded by silence. And somewhere out there, something new is waiting. The story is not over. It's just paused for the night.